Hi students, in this lecture we see the new theorem, derivatives of composite function theorem. In the exam we have to ask this theorem for 3 marks, and if the theorem is with example, then the question is asking for 4 marks, that is derivatives of composite function. What is meant by composite function? That is function of another functions is called as composite function. In standard 11 in functions we already studied in type of function, that is composite function. Composite function is in the form of f of g of x. Functions is of another function is called as composite function. The statement of this theorem is, if y is equal to f of u is a differentiable function of u and u is equal to g of x is a differentiable function of x, such that the composite function is y equals to f of g of x is a differentiable function of x, then dy upon dx is equal to dy upon du into du upon dx. What we have to give here? Y equals to f of u and u equal to g of x. These two statements we have to given here, and we have to prove that dy upon dx is equal to dy upon du into du upon dx. So we prove this theorem. So first given things is what? Y is equal to f of u and u is equal to g of x. Here we consider a smallest increment delta x in x. Smallest increment in x, that is delta x. Also delta y and delta u be the corresponding increments in y and u respectively. There is smallest change in x, that is delta x, and smallest change in delta y, which is in y, and delta u in the function u. Now as x tends to 0, then delta y tends to 0 and delta u also tends to 0, because these two functions y and u both are functions of x, and if x becomes 0, then this y and this u also becomes 0, because these two functions which are depend on the function x. So if delta x tends to 0, then delta y and delta u also becomes 0. Now we have to prove this theorem. So consider an incrementary ratio. Consider incrementary ratio. This type of theorem we already studied in standard 11, that is rules of differentiation, sum of sum, subtraction, multiplication and quotient. Now we see composite function theorem. So what is incrementary ratio? That is delta y upon delta x is equal to delta y upon delta u into delta u divided by delta x, which is an incrementary ratio. We have to prove this in the form of dy upon dx. Now taking limit as a delta x tends to 0 on both sides. Taking limit delta x tends to 0 on both sides. Therefore limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0. So first apply limit delta y upon delta u into delta u upon delta x. Now separate these two limits. Limit delta x tends to 0, delta y upon delta u into limit delta x tends to 0, delta u divided by delta x. Delta x tends to 0, delta y upon delta x. Now as delta x tends to 0, then delta u also tends to 0, because we know that u is a function of x. Therefore we can write here limit delta x tends to 0, delta y upon delta x is equal to limit delta u tends to 0. Since as delta x tends to 0, delta u tends to 0, therefore we change the limit delta x by delta u, because here denominator is delta u, into limit delta x tends to 0 delta u divided by delta x. Say equation number 1. Now we have given that y is a function of u and u is a function of x. Therefore their limits are exist. Since y is a differentiable function of x, u, and u is a differentiable function of x. Y is function of u and u is a function of x. Then what? Then limit delta u tends to 0 delta y upon delta u is equal to what? dy upon du, because this y is a function of u, therefore their limit is exist and it is finite. And limit delta x tends to 0 delta u upon delta x, which is du upon dx, which is again exists since u is a function of x and the limit is finite. Therefore equation 1 becomes, therefore the RHS of equation 1 becomes, what is equation 1? That is limit delta x tends to 0 delta y upon delta x, and this is RHS of equation 1. Therefore RHS of equation 1 becomes limit delta x tends to 0 delta y upon delta x is equal to, instead of this term we write dy upon du, into limit delta u upon delta x, that is du upon dx. Now as RHS of this one is exists, therefore LHS also exists. As RHS of equation first exists, then LHS also exists. Then LHS also exists, and which is finite also, and which is finite. Therefore limit delta x tends to 0 delta y upon delta x is equal to dy upon dx, that is y is a differentiable function of x. So equation first becomes dy upon dx is equal to dy upon du into du upon dx. This is also known as a chain rule. In exam, this theorem is very important, which is asking for 3 marks, or it is asking for 4 marks if this example is with example. Now we take some derivatives of composite functions. Now derivatives of some standard composite function. Derivatives of some standard composite functions. We also studied the derivatives of functions. Now we see derivatives of composite functions. So first, composite function is f of x raised to n, that is function. We know that derivative of x raised to n, that is n into x raised to n. So here derivative of function raised to n, so n into f of x raised to n minus 1 into multiply the derivative of this function. Second, root f of x. We know the derivative of root x, that is 1 upon 2 root x. So here root f of x. So derivative is 1 upon 2 root f of x into multiply the derivative of the function. Next, third one, log f of x. Derivative of log x is 1 upon x. So derivative of log f of x is 1 upon f of x into take derivative of function that is f dash of x. Now derivative of e raised to f of x. We know derivative of e raised to x, that is e raised to x. So derivative of e raised to f of x is e raised to f of x into derivative of function. Next one, a raised to f of x. Derivative of a raised to x is a raised to x into log a. So here derivative of a raised to f of x is a raised to f of x as it is into log a into f dash of x. While finding derivatives of composite function, we have to multiply the derivative of the function. Now derivatives of trigonometric functions. Derivatives of trigonometric composite function. So first one is the sin f of x. We know derivative of sin x, that is cos x. So derivative of sin f of x is cos f of x into multiply the derivative of the function. Next one, cos f of x, that is the derivative is minus sin f of x into f dash. Third one, tan f of x. So derivative is sec square f of x into f dash. Derivative of cot f of x is minus cosec square f of x into f dash of x. Next one, sec f of x. So derivative of sec x is sec into tan. So here instead of x we use function. So sec f of x into tan f of x into f dash of x. And now last one trigonometry is there, cosec f of x, which is minus cosec f of x into cot f of x into derivative of our function, that is f dash of x, which is some functions, composite functions. Now we take some examples. These functions are very important to solve examples. So we will take example. Y is equal to root of x square plus 5. For example, under root x square plus 5. We have to differentiate this function. So first consider let u is equal to x square plus 5. Let's consider under root x square plus 5, that is u is equal to x square plus 5. So this y is equal to, we get root u because this term is consider u. So y is equal to, it becomes root u. So now y is a differentiable function of u. So differentiate with respect to u. Differentiate with respect to u. Now y is a function of u. If y is a function of x, then we differentiate with respect to x. Here y is a function of u. So differentiate with respect to u. So derivative of y is what? Dy upon du is equal to, now derivative of root u, derivative of root x is 1 upon 2 root x. So derivative of root u is 1 upon 2 root u, and use this value u 1 upon 2 root. Value of u is x square plus 5. So equation 1. Now u is equal to what? X square plus 5. Now this u is a function of x, so differentiate with respect to x. Differentiate with respect to x. So derivative of u with respect to x is du upon dx, and derivative of x square is 2x plus derivative of 5 is 0 since it is constant. So we get dy upon du and du upon dx. So by composite function theorem or by chain rule, therefore by chain rule, or we can say by composite function theorem. What? dy upon dx is equal to dy upon du into du upon dx. Therefore, dy upon dx is equal to, from first and second, this is our second equation and this is first equation. So from first and second we write dy upon du is 1 upon 2 root x square plus 5. 2 root x square plus 5 into, what is du upon dx? From 2 to x, which is 2x. So this 2 will get cancelled and the remaining term is x upon root x square plus 5, that is dy upon dx. By using composite function theorem, we can find dy upon dx. Now we will take another example. Y is equal to e raised to tan x. Y is equal to e raised to tan x. So again this is a function of another function, e raised to f of x. E raised to f of x, which is called as composite function. So again consider, let u is equal to tan x. U is equal to what? Tan x. So this y is equal to what? E raised to u. This tan x is equal to is a u. So this function y is equal to, it becomes e raised to u. Now this y is a function of u. So differentiate with respect to u. Differentiate with respect to u. So derivative of y with respect to u is again dy upon du. If y is a function of x, then we write dy upon dx. Here y is a function of u, so dy upon du. Now derivative of e raised to x is e raised to x. So derivative of e raised to u is e raised to u. So what is u? Tan x. So keep e raised to tan x. Now u is equal to what we consider? Tan x. Now this u is a function of x. So differentiate with respect to x. Differentiate with respect to x. Therefore du upon dx is equal to, derivative of tan x is sec square x. Say equation number second and say here equation number 1. So again from 1 and 2 and by chain rule. Therefore by chain rule dy upon dx is equal to dy upon du into du upon dx. Therefore from 1 and 2, what? Dy upon dx is equal to e raised to tan x, that is dy upon du, into du upon dx is sec square x. Is sec square x. Simply if we have a function, any function y is equal to f of x raised to g of x, then the derivative is dy upon dx is equal to, first find the derivative of this function into derivative of our function, which is given in example. Now next one is there, y is equal to log of x raised to 5 plus 4. Log of x raised to 5 plus 4. Again consider u is equal to which term? X raised to 5 plus 4. Therefore again this function y changing into y is equal to log u, because the term in bracket we say this term as a u. Therefore y is equal to log u. Again y is a function of u, so differentiate with respect to u. That is dy upon du is equal to, derivative of log x is 1 upon x. So derivative of log u is 1 upon u. And what is u? x raised to 5 plus 4. Say again equation number 1, and u is equal to what? X raised to 5 plus 4. Now u is a function of x. So differentiate with respect to x. That is derivative of u is du upon dx is equal to derivative of x raised to 5 by power function 5 into x raised to 5u minus 1, that is n into x raised to n minus 1 plus derivative of 4 is 0 since it is constant, and dy upon dx is 5 into x raised to 4. 5 minus 1, that is 4. Say equation number 2. Again by using chain rule we write from 1 and 2 e raised to dy upon dx is equal to dy upon du. First equation 1 upon x raised to 5 plus 4 into du upon dx, that is 5x raised to 4. Therefore dy upon dx is equal to 5x raised to 4 divided by x raised to 5 plus 4 dy upon dx. And in next lecture we take exercise 2.1. Thank you.